Hi everyone, this is Damanam from Edureka, and I welcome you all to this session on DevOps interview questions and answer, where I will tell you all the important DevOps questions that you may face in your interview. By the end of this interview, you will be confident enough to face any DevOps interview and ace it. I will start firstly from a fresher point of view, then move into an intermediate stage, and finally check out the questions and answer from an experienced point of view. But before we get started, make sure to like the video and hit the subscribe button. You can also click the bell icon to receive regular updates from here. If you're interested in any certification, do check out the link shared in the description box below. Now, let us not waste any time and go ahead with the first question. Who is a DevOps engineer? Now, this question may look simple, but what the interviewer does not want you to know is that this question is a trick question. He wants to understand the in-depth knowledge of how prepared are you for the interview, and depending on your answer, he can understand or identify if that person truly has a skill and knowledgeable about the role that you've applied for. Now, a fresher might answer this question like, a DevOps engineer is a person who works with both software developers and the IT staff to ensure smooth code releases. Or they might have answered something like this. A DevOps engineer is someone knowledgeable about the SDLC, or we can say a software development cycle, and automation tools for creating the CI/CD pipeline. Yes, both answer is an accurate description of the role of a DevOps engineer. But I suggest you answer this question something like this. A DevOps engineer works at the intersection of development and operation, and they are responsible for helping to bridge the gap between these two teams. Now, they work with developers to understand the codes and its dependencies, and they work with the IT staff to ensure that the codes can be effectively deployed and maintained in the production environment. Now, DevOps engineers often have a strong background in both development and the operation, and they use this knowledge to help streamline the software development and releases processes. Now, they may be responsible for automating various parts of the process, such as testing, deployment, and monitoring, to improve efficiency and reduce the risk of errors. Now, moving on to the next question, we have why has DevOps become famous? Or why do you think DevOps has become the trend in today's generation or era? The main point in asking you this question is they want to understand from their point of view if you understand the job roles and responsibility in their organization as a DevOps engineer or an architect or an associate, etc., or whatever the job role that you have applied for. Now, you might answer this question by saying DevOps has become famous due to these following reasons: frequent features deployments, then reduce time between bugs fixes, reduce the failure rate of releases, and quicker recovery time in case of release failures. Now, what if I tell you there's a better way to answer this question? So you can say something like a DevOps. DevOps is a software development and delivery approach that emphasizes collaboration and communication between software developers and the IT operation professionals. Now, DevOps has become famous because it allows organizations to deliver software updates and applications faster and more reliable. By automating the build, test, and deployment process, DevOps helps teams to reduce the time it takes to develop and release software. This is essentially important in today's fast-paced business environment where companies need to be able to quickly respond to changing market conditions and customer needs. Now, you can also add more information by saying, additionally, DevOps helps organizations to improve the reliability and stability of their software as well as the security of the system. By adopting DevOps practices, organizations can more easily adopt new technologies and deliver value to the customer faster, which has become a motto for all organizations. Now, coming to the third question, we have what is the use of SSH? Now, you might answer this question like SSH, which stands for Secure Shell, is an administrative protocol that allows users to access and control remote servers over the internet via the command line. You might have also added this part to the answer by saying SSH also includes mechanism for remote user authentication, input communication between the client and the host, and output delivery back to the client. Okay, that is correct. But let us explain to the interviewer your answer to that question in such a way that they understood you have the knowledge and the basics are clear and you know what you are saying. So you can start the answer by saying something like SSH is a secure way to remotely connect to a computer or server and perform tasks as if you were physically present at the location. It is commonly used to remotely administer server, configure and manage network devices, and automate tasks. Then you can add some more inputs to the answer by saying SSH uses encryption to secure the connection between the client, that is your computer, and the server, ensuring that the data transferred over the connection is protected from eavesdropping. This makes it a useful tool for remote access and administration, as it allows users to securely connect to and perform tasks on remote server without worrying about the confidentiality of the data being transmitted. In addition to providing secure remote access, SSH can also be used to transfer files between computers, redirect input and output, and tunnel other protocols such as HTTP, FTP, and Telnet through an encrypted connection. Now, coming to the next question, we have what is configuration management? Now, you can start answering this question by saying it is the systematic handling of changes in such a way that the system does not lose its integrity over time. This includes policies, techniques, procedures, and tools for evaluating, managing, and tracking changes proposal, as well as maintaining appropriate documentation. That is correct. But what if I tell you guys that there is a better way to phrase the answer to this question? So you'll be that candidate that stand up amongst other candidates. Now you can start it by phrasing the answer like this. Now configuration management is a practice that helps organization maintain the integrity and functionality of the system by systematically handling changes to their configuration. It involves identifying, organizing, and controlling the configuration of hardware, software, and related infrastructure to ensure that the system operates as intended and to make it easier to identify and fix problems when they occur. Now, configuration, we can also add, configuration management is an important aspect of IT infrastructure management as it helps organizations keep track of the various components that make up their system, such as servers, storage device, and networking equipments. It also helps organizations maintain consistency and control over the configuration of their system, which is critical for ensuring that they function properly and meet the needs of the organization. Now, to implement the configuration management, organization typically uses a combination of tools, processes, and policies. Some common tools used in the configuration management includes the version control system, configuration management databases, and asset management system. These tools helps organization track and manage changes to their system, as well as keep tracks of the various components that make up their system. Till here, they are already impressed by your answer, but you can go further and add more details to that answer by saying, in addition to tools, organizations also needs to establish processes and policies for managing changes to their system. These processes and policies outline the steps that needs to be taken when making changes to a system, as well as who is responsible for making those changes. This helps ensure that the changes are made in a controlled and consistent manner, which is critical for maintaining the integrity and functionality of the system. Overall, configuration management is a key practice that helps organizations maintain control over the system and ensure that they function properly. It involves the use of tools, processes, and policies to identify, organize, and control the configuration of hardware, software, and related infrastructure in a way that helps maintain the system integrity and functionality. Now, the next question they might have asked you is, what is the importance of having configuration management in DevOps? So basically, this question is a part of the previous question. Now, what they want to see is if you have any knowledge about the tools. So you might answer this question something like, configuration management is important as it assists the team in automating time-consuming and tedious tasks, thereby improving the organization performance and agility. But at this point, we have understood that this is not how we go about with the answer. Those who are a part of our Edureka family know this since they have already had a mock interview preparation test, which helps them deliver the answer in a better way and ace the interview. So let me help you answer this question so that the interviewer will remember you and put you aside from the other candidate. You can answer this question in the following manner. Configuration management is an important aspect of DevOps because it helps organizations maintain control over the system and ensure that they function properly. It allows organizations to identify, organize, and control the configuration of hardware, software, and related infrastructure in a way that helps maintain the system integrity and functionality. Guys, always remember to add key points to your answer in every interview because it is always a good impression. So you can say something like, there are several key benefits to using configuration management in a DevOps environment. First is it has improved efficiency. Now, configuration management tools and processes help automate the management of system and infrastructure, which can improve the efficiency of the development and operation teams. Now, the second benefit is configuration management enhance visibility. Now, what I meant by that is configuration management tools provide a central repository for tracking and managing changes to system, which can improve visibility into the configuration of those systems. Now, the third benefit is configuration management is a better collaboration. Now, configuration management tools and processes help facilitate collaboration between the development and the operation teams by providing a common platform for managing changes to the system. Now, the fourth key benefit of configuration management is its increase in speed. What I mean by this is configuration management can help speed up the delivery of new features and updates by streamlining the process of managing and deploying changes to the system. Now, the fifth benefit and the last benefit is its enhanced security. Now, what I meant by enhanced security is that they can help improve the security of system by helping the organization identify and fix vulnerabilities more quickly and by providing clear record of changes made to the system. Now, we can say overall, configuration management is an essential component of DevOps that helps organizations maintain control over the system and improve their efficiency, speed, and security of their operation. The next question that we have is very important, especially from a fresher point of view, since there is a higher chance that this question will be asked a majority of the time. Now, the question is, what is continuous integration? I've already told you guys that this is an important question, so I will straight away tell you guys how you should deliver this answer to the interviewer. So you can answer this question by saying, continuous integration is a software development practice in which developers regularly merge their code changes into a central repository. The central repository is then built and tested automatically, ensuring that the code changes do not introduce any new defects. One of the main goals of CI is to catch errors as early as possible in the development process. By integrating code changes frequently, developers can detect and fix defects more quickly, rather than waiting until the end of the development cycle to find and then fix a large number of defects all at once. So this can benefit by saving time and resources, which leads to a higher quality final product. Now, you can also explain the workflow of continuous integration as an example to the interviewer. So you can say a developer makes a code changes and pushes it to the central repository. Then the CI system automatically detects the code change and start a build process, as you can see in the diagram on the screen. After that, the CI system compiles the code and runs automated tests to ensure that the code changes has not introduced any new defects. Now, if the build and tests are successful, then only the code is automatically deployed to a staging or production environment. But in case if the build or test fails, the developers is notified and can fix the issue and push the code changes again. So there are many tools available to support the CI, including Jenkins, Travis CI, and Circle CI. Now in DevOps, Jenkins is the most common tool used for continuous integration. Now you can share your experience of your project when you're working and building the pipeline for a DevOps project. Hence, you can say these tools can be configured to automatically build and test code change and to perform other tasks such as deploying code to different environments or triggering other automated processes. In addition to catching defects early in the development process, CI can also help to improve collaboration amongst developers. By integrating code change frequently, developers can see how the changes affect the overall code base and make necessary adjustments. Now, this can help to prevent conflicts and reduce the risk of code breaks. Hence, CI can also improve the overall quality of a software project. That is, by regularly testing and deploying code, developers can ensure that the code base is always in a stable and deployable state. Now, this can make it easier to release new features and updates to customer and can improve the reliability and performance of the software. Overall, continuous integration is a valuable software development practice that helps to improve the quality, the speed, and collaboration of a project. It is an important tool for any software development teams looking to improve its process and deliver high quality product to its customers. You can explain it to them even furthermore by giving them a live example of how working with a continuous integration is a hazardous process and how developers face an issue after working weeks or months on a code, and later on they found out that there were lots of bugs and error in that code. So let us start with an example. Say developers are creating a software model and have worked for 3 weeks straight. Now that is a lot of code, really. Now after 3 weeks, you think that your job is done for now. Now that is what you thought, right? Every developer, suppose they sit there and type for 3 weeks for a single project, and then after 3 weeks they expected like, yeah, they have completed the project and is good to go. As per the process, all this code will be fetched by the build server, and this code is build tested. And later on, they found out that there were lots of errors, bugs, conflicts, and build failures. Now, developers have to fix all these defects. Now they have to rewrite the code at several places, which is a lot of rework, really. So what will this happen is, now this could have been much easier if the problem was detected very early in the process, but then code was collected with defects for 3 weeks, and now they have to fix all of that. So the code is getting merged into the repository but not really getting integrated. The solution to this is very simple if they had used continuous process. Now after every single commit from the developers, the code should be built and tested, so there is no need for waiting and collecting all these code with bugs, but then the developers commit several times in a day, so it is not humanly possible to do the build and release several times in a day. Now what I mean is the manual process. So that is simple. We will just use an automation process. So when the developers commit any code and automated process, it will fetch the code, build it and test it and send a notification if there are any failures. Now as soon as the developers receive a fail notification, they will fix the code and commit it again. So again, build and test new changes. If it is good, then it can be versioned and stored in a software repository, and it is all automated. Like this, any defects can be caught as soon as it's merged with the code. This whole automated process is called continuous integration, or CI for short. Now the goal of CI is to detect defects at a very early stage so it does not multiply. Now after this question, we have a very similar question like earlier, where it is a part of the previous question. So let us go ahead and see the next question. Why is continuous integration needed? So there are two ways to answer this question. Either you can go with the first one or you can go with the second one. But my suggestion is going to be the second one. So it is up to you to decide which answer best suits for you. Now you can start by saying it has been discovered that incorporating continuous integration for both development and testing has improved software quality and drastically reduced the time required to deliver software features. Because each commit to the shared repository is automatically built and run against the unit and integration test cases. The development teams can detect and fix errors early on. So this is one answer, or you can answer this question in this manner. Continuous integration is a software development practice that aims to minimize the time between writing the code and deploying it to the production. It is designed to improve the quality, speed, and collaboration of a software project by catching defects early in the development process and integrating code changes frequently. Now, I have already told you guys and stress out that putting your answer in a key point is a very important and beneficial from an interview point of view. So go ahead and impress the interviewers by saying these following points. Now there are several reasons why CI is an important practice for software development teams. First, CI can help to catch defects early in the development process. By building and testing code changes automatically, CI can help to identify defects and issues before they become more difficult and costly to fix. This can save time and resources and lead to a higher quality final product. Secondly, CI can improve the speed of the development process by integrating code changes frequently. Now, developers can deploy new features and update the customer more quickly. This can be especially important in fast-paced environments where the ability to quickly release new features can be a competitive advantage. Thirdly is CI can improve collaboration amongst developers. Now, by integrating code changes frequently, developers can see how the changes affect the overall code base and make the necessary adjustments. Now, this can also help to prevent conflicts and reduce the risk of code break, which can save times and improve the overall efficiency of the development process. Fourthly, CI can improve the overall quality of a software project. Now, this can be done by regularly testing and deploying codes. Developers can ensure that the code base is always in a stable and deployable state. Now, this can make it easier to release new features and updates to customers and can improve the reliability and performance of the software. Finally, CI can also help reduce the risk of costly failures. By catching defects early in the development process, CI can help to prevent major failures or outage that can be costly and damaging to a company's reputation. Now you can add the conclusion by saying, overall, CI is an important practice for software development teams because it can help to improve the quality, speed, and collaboration of a project. It is an effective way to catch defects early in the development process, improve the speed of the development process, improve collaboration among developers, improve the overall quality of a project, and reduce the risk of costly failures. Now, another important question that a DevOps fresher encounter in an interview is, what is continuous testing? Now, like I said before, some of you out there might just answer and try to get it done with the answer. But a very important point here to highlight is that you should always try to engage as much as possible with the interviewer. Now, in that manner, he knows you not only have the skill, but also the determination and the perseverance. Even if there are some questions that you're not able to answer, instead of being silent, it is always better to engage and ask the doubts of the question from the interviewer, or say something like, can I get back to you on this topic later? Now, you have to make sure that you collect all the information at the end of the interview so that later you can answer those questions. So let us go back to the question, which is, what is continuous testing? Now, the first way to answer this question is, continuous testing is a DevOps phase that entails the process of running automated test cases as part of an automated software delivery pipeline with the sole goal of receiving immediate feedback on the quality and validation of the business risk associated with the automated build of code developed by developers. The best way to answer this question is you say something like this. Continuous testing is a software testing practice in which tests are continuously run, typically in an automated fashion as part of the software development process. Now, the goal of continuous testing is to provide rapid feedbacks to developers on the quality and correctness of their code, enabling them to identify and fix issues as soon as they are introduced. Not only it helps to reduce the time and cost of debugging and fixing issue later in the development cycle, but it can also improve the overall quality and reliability of the software. One key aspect of continuous testing is automation. Now, automated tests can be run much faster and more frequently than the manual tests, and can be run at any stage of the development process, from code check-in to deployment. This enables developers to get feedback on their code changes almost immediately, rather than having to wait for a separate testing phase to be completed. Now, we can also add another important aspect of continuous testing is the use of test framework and test infrastructures that make it easy to run a wide variety of tests, including unit tests, integration tests, and end-to-end tests. Now, these frameworks and infrastructure can be integrated with the development process, allowing tests to be run automatically as code is check-in, build, or deployed. Now, after this, you can add some example to your answer by saying, one example of continuous testing in action is the use of continuous integration system. In a CI workflow, developers check the code changes into a shared repository, and a CI system automatically build and test the code. Now, if the test is passed, the code is deployed to a staging environment where it can be further tested. Now, if the test failed, the CI system can alert the developers and provide them with the information on what went wrong, and in turn enable them to fix the issue and rerun the test. Another example of continuous testing is the use of continuous delivery system. In a CD workflow, code changes are automatically built, tested, and deployed to a production as soon as they are ready. Now, this requires a high level of automation and testing, as well as a robust deployment process to ensure that code changes are released smoothly and without interrupting service. So, continuous testing can be applied to a wide variety of software development projects by saying continuous testing can be applied to a wide variety of software development projects, including web application, mobile apps, and backend services. It can be especially useful in agile development environment where code changes are made and released on a frequent basis. By providing rapid feedback on code changes, continuous testing helps to ensure that software is delivered quickly and with a high level of quality. And the last question for the DevOps interview question for fresher is, what are the three important DevOps KPI or the key performance indicator? Now, to answer this question, you can go about in this way. You can say there are many possible DevOps key performance indicator that an organization may choose to track, and the specific KPI that are the most important will depend on the goals and priorities of the organization. However, some commonly tracked DevOps KPIs include deployment frequency. Now, this KPI measures how often new code is deployed to the production. So, high deployment frequency can be a sign of a well-functioning DevOps process, as indicates that a team is able to quickly and reliably bring new features and fixes to users. Second is lead time for changes. This KPI measures the amount of time it takes for a change to be made to the system. Now, from the time the change is requested until it is deployed to the production. So, the short lead time can be a sign of a streamlined and efficient DevOps process, as it indicates that a team is able to quickly respond to changing business needs. Now, the third key performance indicator is the mean time to recovery. Now, this KPI measures the amount of time it takes to restore service after a failure or an outage. Now, a low MTTR or a mean time to recovery is important for maintaining a high level of availability and ensuring that the system can quickly recover from any disruptions. So you can say these were the three important DevOps KPIs. Since they have specifically asked for just three DevOps KPIs or key performance indicating, so answering it till here will be enough. But if you want to know more about the DevOps KPI, or in case the interviewer asks for more than three DevOps KPI, then you can add the following as well. Now, other possible DevOps KPI includes the change failure rate. Now, this KPI measures the percentage of changes that result in the failure or regression. Now, a low change failure rate is the importance for maintaining the stability and reliability of the system. Then we have the mean time between failures. Now, this KPI measures the average time between the failures or outage. Now, a high MTBF or a mean time between failures is important for maintaining the reliability and the availability of the system. And another important KPI is service level agreement compliance. Now, this KPI measures the percentage of the time that the system is able to meet the service level target specified in the SLA. So, a high SLA compliance is important for maintaining the reliability and the quality of the services. And the last KPI that we're going to talk about here now is the customer satisfaction. This KPI measures the level of satisfaction of the users or customer of the system. So, a high customer satisfaction is important for maintaining a positive reputation and for retaining the customers. So, it is important to know that these are just a few examples of the DevOps KPI, and the specific KPIs that are most important for a given organization will depend on its specific goals and priorities. It is also important to carefully consider which KPI are most relevant and meaningful for the organization, and to track and analyze them over time to gain insight and drive continuous improvement. Now that we have covered the DevOps interview question for freshers, let us dive into the DevOps interview question for an intermediate candidate. So, starting with our first question, we have to explain the different phases in a DevOps methodology. Now, this question is a good question because it will give you an overview of the whole cycle of DevOps. Now, this question is set up in such a manner that the interviewer will get the specific details or level of the candidate. So, let us go ahead and discuss the answer to this question. I will first start by peeling off the basic. So, I will explain the interviewer what is DevOps. Then eventually I will talk about the phases and the tools for each phases in the DevOps. So let me answer this question by saying DevOps is a software development and delivery approach that emphasizes collaboration, communication, and integration between software developers and the information technology professionals. Now, it aims to streamline the process of developing and deploying software by automating many of the tasks involved and by fostering a culture of collaboration between teams. DevOps can be thought of as a collection of practices and tools and principles that enables organization to deliver software updates and application more quickly and reliably. Till here, we have provided the basic definition of DevOps. Now, after this, we will start with our phases step by step. In DevOps, there are several different phases that typically followed as part of the software development and delivery process. So, the first phase is planning. Planning is a crucial phase in the DevOps methodology as it involves defining the goals and objectives of the projects, as well as establishing a roadmap for how the work will be done. So, planning helps to ensure that the project is well defined and that all necessary resources and stakeholders are in place to support its success. During the planning phase, now the team may define and prioritize the features and functionality that will be included in the software or application. They may also establish timelines and milestones for completing each task and deliverables. So, planning may also involve identifying and addressing potential risks and challenges that may arise during the development and deployment process. To support effective planning, teams may use tools such as project management software, version control system, and agile methodologies. Now, these tools can help teams track progress, communicate with stakeholders, and manage changes and updates to the project. Now you can say the conclusion for the planning. So you can say something like, overall, the planning phase in the DevOps helps to establish a clear and cohesive vision for the projects and sets the foundation for the work that will be done in the subsequent development, testing, deployment, monitoring, and maintenance phases. Now you can talk about the second phase, which is development in DevOps. During the development phase, the team are responsible for creating the software or application which will work on writing and testing the code. This may involve using a variety of programming languages and tools depending on the specific requirement of the project. Tools that may be used in this phase include integrated development environment such as the Visual Studio or Eclipse and code repository such as the GitLab or the GitHub. The development phase may also include design and prototyping activities in which the teams work on creating mockups and prototypes of the user interface and other key features of the software. Now, these prototypes can be used to test and refine the design before the final version is developed. Now, the third phase that we'll be explaining is testing. So, we can go about by saying testing is an important part of the development process that helps ensure that the quality and reliability of software. It involves executing a program or system with the intent of finding and fixing bugs or defects and verifying that it meets the specific requirement. There are many different types of testing that can be performed, including unit testing, integration testing, system testing, acceptance testing, and more. There are also a wide range of tools available to help developers and testers perform these tasks efficiently and effectively. Some examples of these tools include the unit testing framework. Now, these tools allows developers to test individual unit or the components of a program in isolation. Examples include JUnit for Java and NUnit for .NET. Another example is integrating testing tools. Now, these tools help testers verify the different components of a system which works together as expected. Examples include SOAP UI for web services, testing, and Selenium for testing web application. Another example is the test management tools. Now, these tools help testers and developers organize and track the progress of their testing efforts. Now, examples include TestRail and TestLink. Then we have the automation tools. Now, these tools allow testers to automate repetitive or time-consuming testing tasks. Now, example includes Selenium and Appium for automating web and mobile app testing, respectively. Then the last example for testing tools is performance testing tools. Now, these tools help testers evaluate the performance and scalability of a system under load. Example includes JMeters and load runners. Overall, testing is a crucial part of the software development process that helps ensure the reliability and quality of the final product. Now, by using a variety of testing tools, developers and testers can more efficiently and effectively identify and fix defects, verify requirements, and improve the overall user experience. Now, coming to the fourth phase in DevOps is deployment. This phase involves releasing the software to production where it is made available to end users. Deployment may involve activities such as infrastructure provisioning, configuration management, and continuous delivery. Now, there are many tools and processes that can be used for deploying software to production, and the tools of which to use will depend on a variety of factors such as the size and complexity of the software, the infrastructure it will be deployed to, and the level of automation desired. Some common tools and processes for deployment include manual deployment, continuous integration and delivery pipelines, configuration management tools, and containerization. So we can explain each one of them in one or two lines. So let us give a brief explanation in one or two sentences on each of these tools and process for deployment. So let's talk about first manual deployment. So this is the most basic method of deployment and involves manually transferring the software to the production environment and configuring it manually. Now this can be done using the tools like FTP clients or the SSH. Second is the continuous integration and delivery pipelines. These are automated systems that handle the build, test, and deployment of software. CI/CD pipelines can be configured to automatically build and test code whenever it is pushed to a version control system like Git and then deploy it into production if all the tests is passed. Next tool is configuration management tools. Now these tools such as Ansible, Puppet, or Chef can be used to automate the configuration and the deployment of software to multiple servers. They allow you to define the desired state of your infrastructure and then use that definition to deploy and manage your software. Now the last is containerization. Tools like Docker allow you to package your application and its dependency into a container, which can then be easily deployed to any environment. Now this makes it easy to deploy software consistently across different environments. Overall, the goal of the deployment is to make the software available to the end users in a reliable and efficient manner. So the choice of deployment tools and process will depend on the specific needs of the software being deployed. Now the fifth phase in DevOps is monitoring. Monitoring is an important phase in the software development lifecycle because it helps ensure that the software is functioning correctly and consistently in a production environment. Now, there are various tools and techniques that can be used to monitor the performance and stability of a software in production. Now, one common technique is log monitoring, which involves collecting and analyzing log files generated by the software. These log files can provide valuable insights into the behavior of the software, such as error messages, resource usage, and performance metrics. Tools such as Splunk, Prometheus, and ELK, that is Elasticsearch, Logstash, and Kibana, can be used to collect, parse, and visualize log data in real time. Another technique is performing monitoring, which involves measuring and tracking various metrics related to the software performance. Now, this can include things like response times, resource utilization, and throughput. Tools such as New Relic, AppDynamics, and Dynatrace can be used to monitor performance in real time and alert when certain thresholds are exceeded. And you can say, in addition to log monitoring and performance monitoring, these are the tools that can be used for incident management and resolution. These tools such as PagerDuty and VectorOps can be configured to automatically send alerts when the issues arises and provide a platform to teams to collaborate on resolving those issues. Now, these tools such as PagerDuty or VectorOps can be configured to automatically send alerts when the issue arises and provide a platform for teams to collaborate on resolving those issues. Overall, monitoring is a crucial part of ensuring that the software is functioning correctly and consistently in a production environment. By using a combination of log monitoring, performance monitoring, and incident management tools, organization can quickly identify and resolve any issue that may arise. Now, the last or the sixth phase is maintenance. So, maintenance is an ongoing phase in the software development life cycle that involves a variety of activities to keep the software up to date and performing well. So, some common maintenance activities include patching. Now, patching involves applying small updates or fixes. This involves applying small updates or fixes to the software to address bugs or vulnerabilities. Patch management tools such as SCCM, that is System Center Configuration Manager, and a big fix can be used to automate the process of applying patches. Next we have is upgrading. So this involves replacing the software with a newer version that includes new features and functionality. Now upgrade tools such as Ansible and Chef can be used to automate this process of upgrading software. Next is we have troubleshooting. Now this involves identifying and resolving issues with the software. Debugging tools such as GDB, that is or a GNU debugger, and an LLDB or an LLVM debugger can be used to identify and fix issues in the software. Other maintenance activities may include optimizing the software for improved performance, adding new features and functionality, and migrating the software to a new platform or environment. Now, to ensure that maintenance activities are carried out efficiently and effectively, it is important to have a well-defined maintenance process in place. This process shall outline the steps that needs to be taken to perform each step of the maintenance activity, as well as the tools and resources that will be needed. It is also important to have a team of trained professionals who are responsible for performing the maintenance activities and ensuring that the software remains up to date and is performing well. As you can see, we have taken this question and explained it for more than 5 minutes. Now I have explained each and every details for this question. I was very clear with the basic along with adding the tools which each phases uses. So let us have a look at the next question. How is DevOps different than the Agile methodology? To answer this question, guys, make sure you set an example for the interviewer. Or what you can do is, first you describe them about the DevOps, and then after that you can talk about the Agile. Now you can compare both of them related with an example. So let us go ahead and answer this question. So we'll start off by understanding the definition of DevOps. So DevOps, you'll start by saying, DevOps is a cultural and technical movement that aims to improve the collaboration and communication between the software developers and the IT operation professionals. Now, the goal of the DevOps is to reduce the time it takes to deliver the software updates and features to customers, and also to improve the reliability and stability of those software updates. We can also add one key aspect of the DevOps is the use of automation tools to facilitate the software development and deployment process. This includes tools for version control, continuous integration, continuous delivery, and infrastructure management. Now, by automating these processes, organization can reduce the time and effort required to develop and deploy the software, and as well as increase the speed and frequency of the software releases. Now, in contrast, the Agile methodology is a project management approach that emphasizes flexibility and rapid iteration. Agile team works in a short cycle known as sprint and use a set of principles and practices known as the Agile Manifesto to guide the work. Some key principles of the Agile methodology include prioritizing customer needs and delivering value early and often. Second is embracing change and adapting to new requirements. Third is collaboration with cross-functionality teams and stakeholders. The fourth point is measuring progress through working software. And the next point is while DevOps and Agile methodology have some overlap, they are not the same thing. DevOps is primarily focused on the technical processes and tools used to develop and deploy software, while the Agile methodology is focused on the project management and delivering value to customer through rapid iteration. So we can add an example to explain to the interviewer. An example of the difference between DevOps and the Agile methodology might be of a software development team that uses Agile principle to manage the project, but also employs DevOps practices to automate the build, test, and the deployment process. In this case, the team is using both Agile project and management techniques and DevOps automation tools to speed up the software delivery process and DevOps automation tools to speed up the software delivery process and improve the quality of the software releases. Now that we have understood the difference between DevOps and Agile, let us move on to the next question, that is, differentiate between the continuous deployment and continuous delivery. This is one of the most frequent asked questions and a two important topic. I will try to be as brief as possible with some scenario examples. So let us see how we should answer this question. Now we can start by saying continuous deployment and continuous delivery are two practices that are often used in the software development process to improve the speed and reliability of delivery updates and new features to users. While they have some similarities, they have distinct practices that serve different purposes and have different requirements. So we'll talk first about the continuous deployment. So we can say that continuous deployment is a practice where code changes are automatically built, tested, and deployed to production environments. So this means that every code changes that passes the automated test is automatically releases to users without any human intervention. Now this can be a powerful way to reduce the time it takes to get updates and new features to users, as there is no need to manually testing or approval processes. Now in a similar manner, we will give the definition of the continuous delivery. So you can start by saying a continuous delivery is a practice where code changes are automatically built and tested but are not automatically deployed to the production environment. Instead, the code changes are made available for review and manual deployment. This means that there is still some human intervention required before code changes are released to the users. But the process is much faster and more reliable than traditional deployment process. So we can give an example to illustrate the difference between continuous deployment and continuous delivery. So say you imagine that you are working on a team that is responsible for developing and maintaining a web-based application. Say your team is using a continuous deployment process, which means that every code change is automatically built, tested, and deployed to production environment. So what happened is one day you made a code changes to fix the bugs in the application. So you commit the code change to the repository and it is automatically built and tested by the continuous deployment system. The test pass and the code change is automatically deployed to the production environment. Within a few minutes, the bug fix is available to all users of the application. Now imagine that your team is using a continuous delivery process instead of a continuous deployment. In this case, you will still make the code change to fix the bug in the same way. However, when you commit the code change to your repository, it will automatically build and test it, but it will not be automatically deployed to the production environment. Instead, the code change will be made available to review by the other members of your team. Once the code change has been reviewed and approved, then it can be manually deployed to the production environment. So this process may take longer than the continuous deployment process as it requires human intervention, but it may be necessary in case where it is important to have a more thorough review of code changes before they are released to the users. Now you can put a conclusion at the end by saying in summary. Now at this point you can add a conclusion by saying a continuous deployment is a practice that automatically build, test, and deploy code changes to production environment, while a continuous delivery is a practice that automatically build and test code changes but requires manual approval and deployment to production environment. Now both practices can help improve the speed and reliability of delivering updates and new features to users, but they serve different purposes and have different requirements. Now moving on to the next question we have, what can you say about the anti-patterns of DevOps? So we can answer this following question by saying an anti-pattern is a common response to a recurring problem that is usually ineffective and risks being highly counterproductive. So in the context of DevOps, anti-patterns can refer to practices or behaviors that hinders an organization's ability to effectively implement and maintain a culture of collaboration between the development and the operation teams. Now, as I said earlier, adding key points gives you some plus point with perspective to the answer. So you can add some point by telling the interviewer, here are some common anti-patterns in the DevOps. Number one is the lack of collaboration between the development and the operation teams. So one of the key principles of DevOps is to foster collaboration between these two teams. So if there is a lack of communication and collaboration, it can lead to silent workflow and fragmented approach to software development and deployment. Second is lack of automation. Automation is a key enabler of continuous delivery and deployment. If an organization is not leveraging automation in its software delivery process, it is likely to face bottlenecks and delays. Now, the third point is lack of monitoring and feedback. It is important to have a robust monitoring and feedback mechanism in place to track the performance of application and identify any issues promptly. If this is not done, it can lead to poor performance and customer dissatisfaction. The next point is the lack of security. Security should be an integral part of the software development and delivery process. If an organization is not prioritizing security, it is at a risk of vulnerabilities and attacks. Now, the next point is lack of experimentation and learning. Now, DevOps encourages a culture of continuous learning and experimentation. Now, if an organization is not embracing this culture, it is likely to miss out on opportunities for innovation and improvement. Now, the next point is over-reliance on a single tool or platform. So it is important to have a diverse set of tools and platforms in the DevOps tool change to enable flexibility and choice. An over-reliance on a single tools or platform can lead to a vendor lock-in and limit an organization's abilities to adapt to changing requirements. Now the next point is inflexible or rigid processes. DevOps emphasizes the importance of flexibility and adaptability. If an organization has inflexible or rigid processes, it is likely to be unable to respond quickly to changing business needs or customers' demand. So by avoiding these anti-patterns and adopting best practices, organization can effectively implement a DevOps culture and realize the benefits of increased collaboration, automation, and continuous delivery. So as you can see, it is always important to finish your answer with a conclusion as it adds more weight to your answer. So that being said, let us move on to the next question. Next question is, can you tell me something about Memcache? You can say Memcache is a free and open source in-memory data store that is used to speed up Dynamics web application by reducing the load on database servers. It does this by storing data in memory for quick access rather than reading from a slower storage device like a hard drive. So some key points and benefits of Memcache are improved performance. So the first benefits of Memcache are improved performance. So by storing data in memory, Memcache allows application to retrieve data much faster than it was stored on a disk. This can significantly improve the performance of web application, especially those that rely on frequent database queries. Second benefit is reduced load on databases. Memcache can help reduce the load on database servers by temporarily storing data in memory and serving it to the user without having to query the database. This can help prevent database bottlenecks and improve the overall system performance. And the next benefit is its high scalability. Memcache is highly scalable and can be easily distributed across multiple servers to handle large amount of data and high level of traffic. Next benefit is the ease of use. Memcache is easy to install and use, and it has a simple API that allows developers to easily integrate it into their application. Now, the next point that we have is it's widely supported. Memcache is widely supported by many programming languages and platforms including PHP, Ruby, and Java. And the last point we have is it's free and open source. Memcache is free and open source software, which makes it an attractive option for developers and organizations looking for a cost-effective solution for improving the performance of their web applications. Now that you have listed down some of the benefits of using a Memcache, you can also give some point related to the drawback. So you can say this to the interviewer. However, there are a few drawbacks of using Memcache. Memcache is not a persistent cache. So what I mean by that is that all the data will be lost when the cache is restarted or the system is rebooted. This can be a problem if you need to store data for a long period of time or if you can't afford to lose any data. Now the second drawback is that Memcache is not designed to use as a database and it does not have the same level of reliability and durability as a database system. This means that you should not use a Memcache as a primary data store or for storing mission critical data. Now another drawback is Memcache is a cache and it is designed to temporarily store data that is expensive to computer or retrieve. What I mean by that is you need to carefully design your cache and validation strategy to ensure that the stale or outdated data is not served to the user. Finally, Memcache is a cache and it is designed to temporarily store data in memory. This means that it is not suitable for storing large amount of data or for storing data that does not fit in the memory. If you need to store large amount of data, you may need to look at other solutions such as distributed database or distributed file system. Finally, Memcache is a cache and it is designed to temporarily store data in memory. What this means is that it is not suitable for storing large amount of data or for storing data that does not fit in the memory. What I mean by that is if you need to store large amount of data, you may need to look at other solutions such as the distributed database or a distributed file system. Now finally, when you are done with the pros and cons of Memcache, it is important to give some common use cases as well. So some common use cases for Memcache include caching the result of expensive database queries to improve the performance of dynamic web application. Second is storing session data to reduce the load on database servers. And the third is catching the result of the API calls to improve the performance of mobile applications. And finally, the conclusion to your answer as usual. So we can go ahead and say this. Overall, Memcache is a powerful tool that can help improve the performance of dynamic web application and reduce the load on databases. It is widely used by organizations of all sizes to improve the user experience of their application. Now let's look at the next question. The next question is, what are the various branching strategies used in the version control system? So let us go ahead and discuss how to frame this answer. You can say something like, in a version control system, branching refers to creating a separate line of development from the main code base. Now what happens is, this allows developers to work on new features or fixes without affecting the main code base. So there are several branching strategies used in the version control system. Number one is trunk-based development. In this strategy, all developers work on a single branch called the trunk or the master branch. This is a simple strategy that works well for small teams with low complexity projects. Now the next point we have is the feature branching. Now in this strategy, developers create a separate branch for each new features they are working on. Now this allows them to isolate their work and avoid conflicts with other developers. When the feature is complete, the branch is merged back into the main branch. Now the next point we have is Git flow. So this is a more structured version of feature branching. It involves creating a develop branch for ongoing development and a release branch for preparing a new release. So what I mean is when a feature is complete, it is merged into the develop branch and then merged into the release branch when it is ready to be released. Now the next point that we have is continuous integration. This is a software engineering practice in which developers integrate the code change into a shared repository several times a day. Now each integration is verified by an automated build, allowing teams to detect problems early. Now the another point that we have is the feature toggling. This is a technique in which new features are developed in a branch and then toggle on and off in the production environment using our configuration settings. This allows teams to deploy new features to production without actually releasing them to the users. Now, next point that we have is release branching. Now, in this strategy, a separate branch is created for each and every release. Now, this allows teams to continue development on the main branch while preparing a stable version for release. Another and the last point that we have is topic branching. So this is a variant of feature branching in which each branch is focused on a specific topic rather than a specific features. And then finally, you can conclude the answer by saying, overall, the best branching strategy will depend on the specific needs and constraint of your teams and project. Some teams may find a simple trunk-based development approach sufficient, while other teams may need a more complex strategy to support their workflow. Overall, the best branching strategy will depend on the specific needs and constraint of your team and project. Some teams may find a simple trunk-based development approach sufficient, while other teams may need a more complex strategy to support their workflow. Moving on to the next question we have, can you list down certain KPIs which are useful for gauging the success of DevOps? As you can remember in the previous questions for Fresher, they have asked the question to mention only 3 important DevOps KPIs. Whereas in the intermediate stage, they have changed the question by asking us to list down these certain KPIs, which means that we have to at least list down 5 or more important KPIs. Even though previously I have discussed more than 3 important KPIs in the DevOps. So let us go ahead and discuss the answer to this question. DevOps key performance indicator are important because they help organization measure and improve the efficiency and effectiveness of the DevOps practices. By regularly monitoring these KPIs, organization can identify areas for improvement and make the necessary changes to their processes and tools. In addition, tracking DevOps KPI can help organizations identify and eliminate bottlenecks, reduce the risk of errors and outage, and improve communication and collaboration between the development and the operation teams. Overall, the use of DevOps KPI can help organizations deliver high-quality products and services to their customers more quickly and reliably. So the first important KPI is the deployment frequency. This measures the number of deployment per day or weeks or months. So a high deployment frequency indicates that the team is able to quickly and efficiently deliver new codes to production. Another point is lead time for changes. This measures the time it takes for the code changes to be deployed to production. Now, a low lead time for changes indicates that the team is able to quickly and efficiently deliver new codes to production. The next key important performance point is mean time to recovery, or MTTR. Now, this measures the times it takes to recover from the failure or an outage. So, a low MTTR indicates that a team is able to quickly and efficiently resolve issue when they arises. Now, the next point is the change of failure rate. This measures the percentage of changes that results in failures or errors. A low change failure rate indicates that the team is able to successfully deploy code changes without introducing errors. The next point that we have is time to restore service. This measures the times it takes to restore service after an outage. A low time to restore service indicates that a team is able to quickly and efficiently resolve issue when they arises. Next point that we have is customer satisfaction. And this measure how satisfied customers are with the product or service being provided. So a high customer satisfaction score indicates that a team is delivering a high quality product or service. The next point that we have is defect escape rate. And this measures the percentage of defects that escapes into the production. A low defect escape rate indicates that a team is effectively detecting and fixing defects before they are deployed to the production. Now, the next point that we have is quality of code. Now, this can be measured using code review metrics, such as the percentage of code that is reviewed, the percentage of defects found during the code review, and the percentage of defects found after the code is deployed to the production. So, a high quality of codes indicate that the team is writing a high quality and a well-tested code. Now, the next point that we have is a code coverage. Now, this measures the percentage of code that is covered by the automated test. So, a high code coverage indicates that the team is writing a well-tested code. The next point we have is the continuous integration and delivery pipeline stability. Now, this measures the stability and reliability of the CI/CD pipeline. A stable and reliable CI/CD pipeline is essential for enabling a high deployment frequency and a short lead time for changes. Overall, these KPIs can help teams understand how well their DevOps implementation is working and identify areas for improvement. It is important to note that these KPIs are just a starting point, and teams will choose the ones that are most relevant to their specific goals and needs. So now let us move on to the next question, which is what is CBD in DevOps? Go ahead and answer this question. You can start by saying a CBD in DevOps refers to a continuous build and deployment. It is a software development practice that involves automatically building, testing, and deploying code changes. This is typically done using a combination of automation tools and processes. Now, the goal of CBD is to enable rapid, reliable, and repeatable deployment while minimizing the time and effort required to get code changes into the production. This is accomplished by automating as much of the build, test, and deployment process as possible. One example of CBD in action might involve a developer making a code change, committing that change to a version control system, and then triggering an automated build process. This process might involve compiling the code, running unit tests, and packaging the code into a deployable artifacts like Dockers or container. Like for example, a Docker container. One example of CBD in action might involve a developer making a code change, committing that change to a version control system, and then triggering the automated build process. This process might involve compiling the code, running unit tests, and packaging the code into a deployable artifacts. For example, a Docker container. Now, once the build process is complete, the artifact is automatically deployed to a staging environment for further testing. This might involve running integration tests, performance tests, and other types of tests to ensure that the code is ready for production. Now, if the tests in the staging environment pass, the code is then automatically deployed to the production. This might involve rolling out the codes to a subset of servers first, and then gradually rolling it to all the servers in order to minimize the risk of introducing new problems. So a CBD can help organizations to release code changes more quickly while also increasing the reliability and stability of their system. This is because automated build and deployment are typically faster and more consistent than manual processes, and they can help to catch errors earlier in the development process. Now, in addition, CBD can help to reduce the risk of human errors since manual steps are minimized. Now, this can be particularly beneficial in complex environments with multiple teams and systems where it can be difficult to coordinate and track manual processes. Overall, CBD is an important aspect of DevOps culture, and it can help organizations to deliver value to their customers more quickly while also improving the reliability and stability of their system. Now, the next question that we have is what is resilience testing? Now, resilient testing, you can go about with the question as resilient testing is a type of testing that is focused on evaluating the ability of a system, components, or process to withstand external stressors or shocks and to continue functioning properly. Now, this type of testing is often used to evaluate the robustness and reliability of systems that are critical to the operation of an organization, such as those that are responsible for providing essential services or that are used in mission critical applications. Resilience testing can be used to evaluate a wide range of systems and components, including hardware, software, networks, and processes. It can be performed at a various level of testing, including unit, integration, and acceptance testing. Now, after you have stated the definition, you can add some different resilient approaches. So you can continue the answer by saying there are several different approaches to resilience testing, depending on the specific needs of the system being evaluated. Now, some common method includes stress testing, disaster recovery testing, fault injection testing, and load testing. So we're going to talk about each one of them to the interviewer. So we can start by saying stress testing. This involves subjecting a system to extreme levels of loads or stress in order to evaluate its performance and determines its limits. Now, this can include testing with high levels of traffic, large amount of data, or other types of stressors. Now, the second point is disaster recovery testing. Now, this involves simulating a disaster or other catastrophic event in order to evaluate the effectiveness of a system disaster recovery plan. This can include testing the system ability to recover from data loss, hardware failures, or other types of failures. The next point is the fault injection testing. This involves intentionally introducing faults or errors into a system in order to evaluate its abilities to handle these types of failure and recover from them. Next one we have is fault injection testing. Now, this involves intentionally introducing faults or error into a system in order to evaluate its ability to handle these types of failures and recover from them. Next and the last point is the load testing. Now, this involves evaluating the performance of a system under normal or expected levels of loads or traffic. Now, this can be used to identify bottlenecks or other performance issues that may not be evident under normal operation. So as you can see, there are a number of benefits to perform resilient testing. For example, it can help organizations to identify and address potential vulnerabilities or weakness in the system before they become a problem. It can also help to ensure that the system are able to recover quickly and effectively from failures or disruption, which can help to minimize downtime and other negative impacts. There are also a number of challenges that organizations may face when performing resilient testing. For example, it can be difficult to accurately simulate real-world stressors or disasters, and it can be expensive and time-consuming to perform. Additionally, resilient testing may require specialized equipment or facilities, and it may be necessary to coordinate with the other organization or stakeholders in order to perform the testing effectively. Now, overall, resilience testing is an important tool for evaluating the robustness and reliability of a critical system and ensuring that they are able to function properly in the face of stresses or disruptors. By performing this type of testing, organization can better understand the limits of the system and take steps to improve the resilience and reliability. Now, moving on to the next question, we have, can you differentiate between continuous testing and automation testing? Now, as I said earlier, when a comparison question is being asked, it is always good to separate each definition and compare them with an example. So you can answer this following question by saying, a continuous testing is a software testing practice in which testing is performed throughout the development process rather than being limited to a specific stage or phases. This can involve a wide range of testing activities, including unit testing, integration testing, system testing, and acceptance testing. Now, the goal of continuous testing is to ensure that the software is being developed is of high quality and is ready for release at all times. Now, when we talk about the automation testing, on the other hand, is a testing approach in which test cases are executed automatically using specialized software tools. These tools can be used to create and run test scripts, which are a set of instructions that specify the steps that needs to be taken in order to test a particular features or functionality of that software. Automation testing is often used to reduce the time and effort required to perform testing, as well as to improve the consistency and accuracy of test results. Now you can continue the answer by saying, One key difference between the continuous testing and automation testing is that the continuous testing is focused on the overall testing process, whereas the automation testing is focused on the use specialized tools to execute test cases. Now, continuous testing may involve a variety of testing techniques and approaches, including manual testing and automating testing, while automation testing is specifically focused on the use of automated tools to execute test cases. So here you can put an example to illustrate the difference between a continuous testing and automation testing. Imagine that a team of software developers is working on a new application. Now, as part of the development process, they practice continuous testing, which means that they are constantly testing the software to ensure that it's of high quality and ready for release. Now, to do this, they use a variety of testing techniques and approaches, including manual testing and automation testing. For example, they may use automation testing to create and run test scripts that automatically execute a set of test cases for particular features or functionalities of the software. Now, this can help to save time and effort as well as to improve the consistency and accuracy of the test results. Now, at the same time, the team is also performing manual testing, in which they manually test the software by manually executing test cases. At the same time, the team is also performing manual testing, in which they manually set the software by manually executing test cases and verifying the results. Now, this type of testing is important for evaluating the usability and user experience of the software, as well as for identifying any issues that may not be able to detect by automated tests. Overall, the team is using a combination of continuous testing and automation testing to ensure that the software they are developing is of high quality and is ready for release. Continuous testing helps them to ensure that they are constantly testing the software, while automation testing helps them to save time and effort by automating the execution of test cases. Now, keep in mind that the next 4 questions that we'll be discussing is very important and you will definitely find it in your next DevOps interview. Now, starting with the first important question is, can you say something about the DevOps pipeline? So we can start answering the question by first stating what exactly is a pipeline and why is it used. So let us begin with the answer. The DevOps pipeline is a set of processes and tools that enables an organization to develop, test, and deploy software quickly and reliably. It is designed to facilitate collaboration and communication between the development and the operation teams, and to enable the rapid delivery of software updates and new features. At a high level, a DevOps pipeline typically consists of the following stages. This is the process of writing and testing codes for a software application. It typically involves a team of developers working together to create new features and functionality and fix any bugs or issues that are discovered. Then after that, we have the version control. This is the process of storing and managing different versions of the software code base. It is typically done using a version control system such as Git, which enables developers to track changes to the code over time and to collaborate on code development. After version control, we have your build and packaging. This is the process of taking the code that has been developed and creating a package that is ready to be deployed. This may involve compiling the code, packaging it into a deployable format, and running any necessary tests to ensure that it is ready for deployment. After the build and packaging comes testing. Now, this is the process of evaluating the quality and the functionality of the software. It may involve running a variety of different tests, including unit tests, integration tests, system tests, and the acceptance tests. Now, when the testing part is done, comes the deployment. Now, this is the process of releasing the software into a production environment where it can be used by the end users. Now, this may involve installing the software on the server, configuring any necessary infrastructure, and performing any necessary updates or upgrades. Well, after the deployment pipeline is done, then comes the monitoring and the maintenance. Now, this is the process of monitoring the performance and stability of the software and taking any necessary action to fix any issues or problems that are discovered. Now, it may also involve implementing updates or new features on an ongoing basis. Now, giving an example is always beneficial because it adds more depth to your answers. A key aspect of the DevOps pipeline is automation. Many of the processes and tasks involved in the pipeline can be automated using specialized tools and platforms which can help to improve the efficiency and reduce the time and effort required to deliver software updates. Giving an example is always beneficial because it adds more depth to your answer. So you can illustrate an example to the interviewer by saying, imagine there's a team of developers working on a new web-based application for a retail company. Now, the application will allow customers to browse and purchase products online. The development team begins by writing and testing code for the application using a version control system such as Git to track changes to the code base. As they work, they frequently commit the code change to the version control system, which enable other teams members to review and collaborate on the development process. Now, once the code is ready for deployment, the build and packaging stage begins. Now, the code is compiled and packaged into a deployable format, and a set of automated tests is run to ensure that it is ready for deployment. Next, the testing stage begins. Now, the application is tested using a variety of different testing, including unit tests, integration tests, system tests, and acceptance tests. Now, this test helps to ensure that the application is of high quality and is ready for release. Now, once the testing is complete, the application is ready for deployment. It is released into the production environment where it is available for use by the end users. The team also set up monitoring and maintaining processes to ensure that the application is stable and performing well. The team also set up monitoring and maintaining processes to ensure that the application is stable and performing well, and to identify and fix any issue that may arise. Overall, the DevOps pipeline is a key component of a successful software development process. By using a combination of automation and collaboration, organization can deliver software updates and new key features more quickly and reliably, and can improve the quality and stability of the software. Now, moving to another important question we have is, tell me something about the Ansible work in DevOps. So let's begin with the answer. First, we will explain the definition, then its benefits, and later on we will explain the workflow of Ansible. So let us get started with the answer. So Ansible is a powerful open source tool that is used in the field of DevOps for automating infrastructure, cloud provisioning, application deployment, and many other IT tasks. So it is written in Python and uses simple YAML syntax to describe the desired state of the system. One of the key benefits of Ansible is that it is agentless, meaning that it does not require any software to be installed on the server being managed. This makes it easy to get started and reduce the maintenance overhead of keeping agents up to date. So Ansible works by connecting to your server and executing tasks based on a set of instructions called the playbooks. Now these playbooks are written in YAML and describe the steps that should be taken to bring the system to the desired state. For example, you might use a playbook to install a package, update the system configuration, or deploy an application. Ansible uses a concept called idempotency to ensure that the desired state is achieved and maintained. So this means that if a task has already been completed, running it again will not make any changes to the system. This is useful because it allows you to run your playbook repeatedly without worrying about causing unintended changes to the system. Ansible also has a rich ecosystem of community-developed modules that can be used to automate a wide range of tasks. Now, these modules can be used to manage systems, networks, and applications, and can be easily incorporated into your playbook. Now, in addition to its automation capabilities, Ansible also have a strong focus on security. It uses a secure shell to connect and manage servers, and all communication is encrypted. Now, this helps to ensure that the sensitive data is protected during the transaction or the transmission. So let me give you an example of how Ansible might work in a real-world DevOps project. A team is working on a web application that is hosted on a cluster of servers. Now, they are using Ansible to automate the provisioning and configuration of the server, as well as the deployment of code updates to the application. The team has defined a series of Ansible roles that corresponds to different aspects of the application's infrastructure, such as the web servers, database servers, and the load balancers. Now, these roles are defined using the YAML files, which specify the tasks that should be performed to set up and configure each component. Now, the team has also set up an Ansible playbook, which is a high-level description of the overall deployment process. The playbook calls the various roles in a specific order, ensuring that all the necessary components are properly set up and configured. To deploy a new code updates, the team simply pushes the changes to their version control system and then run the Ansible playbook on the cluster of servers. Ansible handles the rest by automatically deploying the code, updates, and performing any necessary configuration tasks. Now, this allows the teams to deploy updates to the application quickly and reliably, without having to manually log into each server and perform the task manually. Also helps to ensure that the server are consistently configured, which is important for maintaining the stability and performance of the application. Now, overall, Ansible is a powerful and flexible tool that is widely used in the DevOps community for automating a wide range of the IT tasks. Its agentless architecture, idempotent design, and rich ecosystem of community developed module makes it an appealing choice for many organizations. Now, coming to the next important question is how AWS contribute to DevOps. Now, as usual, we can start answering this question by understanding what is AWS, then what are the benefits of using AWS, and then finally see how AWS contributes to DevOps. Now, let us start with the answer. Now, AWS or Amazon Web Services is a cloud computing platform that provides a variety of services that can be used for the development, deployment, and management of applications. These services can be particularly useful for organizations that are practicing DevOps, which is a software development approach that emphasizes collaboration, automation, and continuous delivery. Now, one of the key benefits of using AWS for DevOps is that it provides a wide range of tools and services that can help to automate and streamline various aspects of the development and the deployment process. For example, the AWS code pipeline is a continuous delivery service that can be used to automate the build, test, and deploy phases of the software development lifecycle. Now, this can help to reduce the time it takes to get new features and updates into the hands of users, as well as improve the reliability and stability of the software. Now, another important services provided by AWS is AWS Code Build, which is a fully managed build service that can be used to compile, test, and package code. Now, this can be particularly useful for organizations that are using a variety of programming language and framework, as code build can be configured to work with a wide range of tools and technologies. In addition to these tools, AWS also provides services for containerization and orchestration, which can be crucial for organizations that are looking to adopt on microservices architecture. For example, AWS Fargate is a serverless compute engine for containers that can be used to run and manage containerization application without the need to manage the underlying infrastructure. Now, this can help reduce the complexity of the development and the deployment process, as well as improve the scalability and reliability of the application. AWS also provides a wide range of services for monitoring and logging, which can be critical for organizations that are looking to maintain visibility into the performance and the health of their applications. For example, AWS CloudWatch is a monitoring service that can be used to track metrics and respond to system-wide events. This can help to identify and troubleshoot issues quickly, as well as proactively prevents problems from occurring. Now, overall, AWS provides a wide range of tools and services that can be used to support DevOps practices, including services for continuous delivery, build and test automation, containerization, orchestration, and monitoring. So these services can help to improve the efficiency and effectiveness of the software development process, as well as enable organizations to deliver high-quality software to their customers more quickly and reliably. Now, coming to the last question in DevOps interview question for an intermediate level, we have what can be a preparatory approach for developing a project using the DevOps methodology. Now, this question is essential for them to gauge your skill and experience. So let us focus and make sure you're prepared to ace this commonly asked question in the interview. So let me tell you guys how to go about this question. So you can start by saying, preparatory approach for developing a project using the DevOps methodology can involve several stages, as outlined below, along with the project's example to illustrate each stages. So we can start with the first point, that is a plan. Now, the first step is the preparatory approach for a DevOps project is to plan and come up with the roadmap for the implementation. Now, this involves performing a thorough assessment of the already existing processes to identify areas of improvement and blind spots. Say, for example, suppose you are working on a project to develop a new e-commerce platform for a retail company. Now, during the planning stage, you will first analyze the current process for building and maintaining the company existing platform. This might involve looking at how the code is developed, how it is tested and deployed, and how the infrastructure is being managed. Next is based on this analysis, you will then identify the area when the process can be improved, such as by automating certain tasks or introducing new tools and technologies. Now, once you have a clear plan in place, the next step is to start developing the code for the project. Now, this involves writing the code using appropriate coding standards and practices, as well as integrating automated testing into the development process. Continuing with the e-commerce platform example, you might start by writing the code for the various features and functionalities that will be included in the platform, such as the ability to browse and purchase products, manage user accounts, and process payments. As you write the code, you will also make use of automated testing tools to ensure that it is of high quality and free of defects. After your code is done, then we have the build. Now, once the code has been developed, the next step is to build and package it into a deployable artifact using continuous integration tools. So, CI tools also allows you to automatically build and test the code whenever changes are made, ensuring that it is always in a deployable state. So, for the e-commerce platform, you might use a CI tools like Jenkins or Travis CI to build the code and create a deployable package such as Docker container or a zip file. Now, you can then use this package to deploy the code to the staging or the production environment. In the testing stage, you will use automated testing tools to ensure that the code meets the required quality standards. Now, this might involve running unit tests, integration tests, and performance tests to validate the functionality and performance of the code. Now, for the e-commerce platform, you might use tools like JUnit or Selenium to run a suite of tests on the code to ensure that it is working as expected and is ready for deployment. Now, once the code has been tested and is deemed ready for deployment, the next step is to release it into the staging or production environment. Now, this can be done using deployment automation tools, which allows you to automate the process of releasing code into different environments. For the e-commerce platform, you might use a deployment automation tools like the Ansible or Terraform to release the code into the staging environment, where it can be tested further before being deployed to production. The deployment stage involves using infrastructure as code or simply IAC tools to deploy and manage the infrastructure required for the project. IAC tools allows you to define the infrastructure needed for the project in codes, make it easier to manage and deploy. For the e-commerce platform, you might use the IAC tools like CloudFormation or Terraform to deploy the necessary infrastructure such as servers, load balancer, and databases. So this allows you to easily and quickly spin up the necessary resources to run the platform. Now, once this project is deployed, the next step is to monitor it in the production and make any necessary updates and optimization. So this might involve monitoring the performance of the platform and identifying any issues that needs to be addressed. It might also involve making updates to the code or the infrastructure to improve the performance or stability of the platform. For the e-commerce platform, you might use tools like the New Relic or Datadog to monitor the performance of the platform and identify any issues that needs to be addressed. You might also use tools like Ansible or Terraform to make updates to the infrastructure or the code as needed. The final step in the preparatory approach for a DevOps project is to continuously monitor and improve the processes and tools used in the project to increase the efficiency and the effectiveness. Now, this might involve adopting new tools and technologies, fine-tuning existing processes, or experimenting with different approaches to see what works best. Now, for the e-commerce platform, you might periodically review the tools and processing being used to see if there are any areas where they can be improved. Now, this might involve experimenting with different CI/CD tools for adopting new technologies to make the development and deployment process more efficient. By continuous optimizing the process and tools used in the project, you can ensure that the project is always running smoothly and meeting the needs of the business. So that was the overall approach for developing a project using the DevOps methodology. Now that we have covered the important questions in the intermediate level, let us jump into the top important interview questions for an advanced or an experienced level. Now let us start with our first question. So the first question is, can you explain the shift left to reduce failure concept in DevOps? Now, to understand what this means, we must first understand how the traditional SDLC cycle works. The traditional cycle has two major sides. The planning, designing, and development phases comprises the cycle's left side, and stress testing, production staging, and user acceptance are all part of the cycle's right side. So, shifting left in DevOps simply means moving as many tasks that normally occur at the end of the application development process as possible into the earlier stages of application development. As you can see from the graph, if the shift left operations are followed, the chances of error occurring during the later stage of application development are greatly reduced because they will have been identified and solved during the early stages. Now, one of the most common way to achieve shift left in DevOps is to have a collaboration with the development team to create deployment and test case automation. So this is the first and the most obvious steps towards shifting left. This is done due to the well-known fact that failures in the production environment are frequently not seen earlier. These failures can be traced back to the development team's use of various deployment procedure while developing these features. Then a second common ways is production deployment procedure are not always the same as development procedures. There may be difference in tooling and the process may also be manual at times. Now, both the development and the operation teams are expected to take ownership of developing and maintaining standard deployment procedures that make use of the cloud and pattern capabilities. So this contributes to the assurance that the production deployments will be successful. Pattern capabilities are used to avoid configuration inconsistencies in the various environments being used. So this will necessitate collaboration between the development and the operation teams to create a standard process that guides developers in testing their application in the development environment in the same way that they test in the production environment. Then we can further say to implement a shift left strategy in a DevOps environment, it is important to have the right tools and processes in place. So this may include continuous integration and continuous delivery tools that allow developers to build, test, and deploy code quickly and efficiently. It may also involve adopting agile development methodologies, which emphasizes rapid iteration and the early and continuous delivery of valuable software. In summary, shift left is a practice in the software development and testing process that aims to detect and fix issues as early as possible in the process. By shifting activities that are typically done later in the process to earlier stages, companies can improve the quality of their product, reduce risk, and increase efficiency. Now, coming to the next question we have, do you know about post-mortem meeting in DevOps? So let us see how we can answer this following question. In the context of DevOps, a post-mortem meeting, also known as a post-incident review or a post-incident debrief, is a meeting that takes place after an incident has occurred in order to review what happened and identify what can be done to prevent similar incidents from occurring in the future. Now, the goal of a post-mortem meeting is to improve the system or process that has involved in the incident rather than assigning blame to individuals. So, post-mortem meeting can be helpful for a number of reasons. They provide an opportunity for teams members to come together and discuss the incident in a structured way and to identify any problems or issues that may have contributed to the incident. They also allow teams members to share their insight and perspective on what happened, which can help to identify the root causes and the potential solutions. There are a few key steps that should be followed in a post-mortem meeting. Number one is review the incident. Now, this involves discuss what happened, including the symptoms, causes, and the impact of the incident. Now, the second is identifying the root causes. Now, the team should work together to identify the underlying cause of the incident rather than just the symptoms. Next is determine corrective actions. Based on the root cause identified, the team should brainstorm potential solution or corrective action that could prevent similar incidents from occurring in the future. Coming to the next point, we have implement corrective actions. Now, the team should work together to implement the agreed upon corrective actions. Then we have the follow-up. So it is important to follow up on the corrective actions to ensure that they have been implemented effectively and that the issue has been resolved. Postmortem meetings can be an effective way to improve processes and systems. but they are only as useful as the actions that are taken as a result of them. It is important to follow through on a corrective actions that are identified and to keep track of their effectiveness over time. Coming to the next question, we have what is the concept behind sudo in Linux operating system? So let us see how to go about with this answer. The sudo command in Linux allows the user to execute command as another user, usually the super user or the roots. This is useful in cases where a user needs to perform actions that require elevated privileges, such as installing software or modifying system files. When the user tries to run a command using sudo, the system checks for the following to see if the user is allowed to run the command as another user. If the user is allowed, then the system prompts for the user's password, and if it is entered correctly, then it runs the command. If the user is not allowed, the command is not run and the user is given an error message. One of the benefits of using sudo is that it allows the system administrator to grant specific users the ability to run specific commands as another user, rather than giving all users full root access. Now, this can improve the security by limiting the actions that users are able to perform on the system. However, there are a few potential downsides to using sudo. One is that it can be confusing for users who are not familiar with it, as they may not understand why they are being prompted for a password when they're trying to run certain commands. Another is that it requires an additional step for users to run commands that require elevated privileges, which can be inconvenient. Overall, sudo is an important tool for managing user privileges on a Linux system. It allows the system administrator to grant specific users the ability to perform specific tasks that require elevated privileges, while also providing a means of logging and auditing the commands that are run on the system. So that was about the concept behind sudo in a Linux operating system. Now moving on to the next question we have, can you explain the architecture of Jenkins? As you all know, Jenkins is the most important tools used in DevOps. So let us see the explanation of the following question. Jenkins is a popular open source continuous integration and continuous delivery tools that is used to automate the build, test, and deployment of software projects. Now you can see here is an overview of the architecture of Jenkins. Now we have the master-slave architecture. Now Jenkins uses a master-slave architecture to distribute the build and test loads to multiple machines. The master node is responsible for scheduling and dispatching build jobs to the slave nodes, as well as recording the build results and publishing the artifacts. The slave nodes are responsible for executing the build jobs assigned to them by the master. This allows Jenkins to scale to support large and complex projects with many builds and tests. Now the next we have is the plugins. Now Jenkins has a rich plugin ecosystem that allow it to integrate with a wide variety of tools and services. For example, you can use the plugin to integrate Jenkins with a version control system like Git, test tools like JUnit, and deployment tools like Ansible. Now this allows Jenkins to customize to fit the needs of your projects. Next we have is the web UI or the user interface. Jenkins provides a web-based user interface that allows you to configure and manage your builds, as well as view the build results. The web UI is accessible from any web browsers, which make it easy to use Jenkins from anywhere. So here's an example of how Jenkins could be used in a project. A developer pushes code changes into the project Git repository. Jenkins now receives a notification of the code change and trigger a build of the project. Now the Jenkins master node dispatches the build job to a slave node. The slave node checks out the code from the Git repository and run the build script, example like a Maven build. Now if the build is successful, Jenkins publishes the build artifact in a jar file to a repository that is your Nexus. Now Jenkins sends a notification to the development teams about the build status. Now if the build is successful, Jenkins can also trigger automated tests and deployments. I hope this helps. Now let me know if you have any questions about Jenkins or would like to know more information. This architecture allows Jenkins to scale horizontally by adding additional slave nodes as needed to handle the workload. It also allows the master to delegate tasks to slaves that have the necessary resources and tools to execute them, which can improve the efficiency of the build process. Now coming on to the next question we have, can you explain the infrastructure as code concept? Let us see how we shall answer this following question. Infrastructure as code is a software development practice in which infrastructure is treated as a version entity that can manage using version control system, just like the application code. The goal of an infrastructure as code is to allow users to create, manage, and deploy infrastructure in a repeatable and automated way. One key benefit of IAC is that it allows infrastructure changes to be tracked and audited in the same way the code changes are. It also makes it easier to roll back changes if something goes wrong. This can be particularly useful when managing large and complex infrastructure environments that include many different components. Infrastructure as code refers to the practice of managing infrastructure in a version control file rather than manually configuring resources through a user interface. The imperative approach is similar to writing a script or a set of instructions that tells the system exactly what to do in order to achieve the desired outcome. It is similar to how you will manually set up and configure your infrastructure. The declarative approach, on the other hand, involves defining the desired state of the infrastructure and letting the system figure out how to reach that state. This approach is more like writing a configuration file that specifies what the end result should look like rather than specifying the steps that it needs to get there. Now, both approaches have their own benefits and drawbacks, and it is up to the users to decide which one is more suitable for their needs. Now, there are several tools and technologies that can be used to implement the IAC, including configuration management tools such as Ansible, Chef, and Puppet, which allow users to describe and manage the desired state of their infrastructure. CloudFormation and Terraform, which are tools for creating and managing infrastructure on cloud platforms such as AWS and Azure. Custom scripts and tools that allow users to automate infrastructure tasks using languages such as Python or Bash. Now, IAC can be applied to a wide range of infrastructure components, including servers, databases, networking configuration, and many more. So by using IAC, organization can more easily manage and maintain the infrastructure in a consistent and reliable way. Now moving on to the next question we have, what is pair programming? A pair programming is a software development technique in which two programmers work together at one workstation. Now one programmer called the driver writes code while the other called the observer or navigator review each line of the code as it is typed in. So the two programmers switch roles frequently. Pair programming can be an effective way to reduce defects in code, improve code readability, and share knowledge among team members. It can also be an effective way to train new programmers or to familiarize programmers with a new code base. Now coming to the next question we have, what is a blue or green deployment pattern? Now let us see how to answer this following question. Blue-green deployment is a strategy for rolling out updates to software systems that allows for minimal downtime and disruptions to users. Now the basic idea is to maintain two identical environments, one called blue and the other called green. So the blue environment is the current production environment, where the green environment is a new version of the software that has been deployed but is not yet live. To perform a blue or green deployment, the new version of the software, that is the green version, is first deployed into the green environment. Now this can be done by building the software and deploying it into the staging environment, or by using a continuous delivery pipeline to automatically build and deploy the software. Now once the green environment is up and running, traffic is redirected from the blue environment to the green environment. Now this can be done using a load balancer or by changing the DNS records to point to the green environment. Once the traffic has been redirected, the blue environment can be taken offline for maintenance or decommission. Now this allows the teams to roll back to the blue environment if there are any issues with the green environment without any downtime or disruptions to the users. For example, let's say you have a web application that you want to update. Now the current version of the application is running in the blue environment, and you have to deploy a new version of that application to the green environment. Now to perform the blue or green deployment, you will first test the green environment and to ensure that it's working properly, right? So once you are confident that the green environment is stable, you will redirect traffic from the blue environment to the green environment using a load balancer or a DNS records. Now once the traffic has been redirected, you can take the blue environment offline or you can decommission it. There are several benefits to using a blue-green deployment. First, it allows you to minimize downtime and disruptions to users. Since traffic is redirected from the old version of the software, to the new version with minimal downtime. Second, it allows you to easily roll back to the previous version if there are any issues with the new version, since the blue environment is still available. And then finally, it allows you to test the new version of the software in a production-like environment before it goes live, which can help identify any issues before they are impacted by the users. In summary, you can say a blue-green deployment is a useful strategy for rolling out updates to software systems that allows for minimal downtime and disruptions to users while also providing a way to easily roll back to the previous version if necessary. Now moving on to the next question, we have what is dogpile effect and how can it be prevented? So let us see how to explain the following question. So the dogpile effect is a phenomenon that can occur when a website becomes temporarily unavailable or slow down due to high influx of traffic. Now, this can happen for a variety of reasons, such as when a popular website links to the target site, now when the target site is featured in the news, or when the target site experiences a sudden surge in traffic due to a viral event. Now, to prevent the dogpile effect, it is important to ensure that a website has sufficient capacity to handle large amount of traffic. This can be achieved through a variety of measures, including scaling up the website infrastructure. This can involve adding more servers, increasing the size of existing server, or implementing a content delivery network to distribute traffic across multiple servers. The second is optimizing the website for performance. This can involve minimizing the size of website codes and assets, implementing caching mechanism, and optimizing the website database. And the third is implementing rate limiting. This involves limiting the number of requests that a website will accept from a single user or an IP address within a certain time frame. Now, this can help prevent the website from being overwhelmed by excess traffic from a single source. Now, the last point is by monitoring the website performance. Now, regular monitoring of the website performance can also help to identify potential issues before they become major problems. Now, this can involve monitoring the website uptime, response times, and error rates. Now moving on to the next question, we have what are the steps to be undertaken to configure Git repository so that it turns the code sanity checking task before any commits? And how do you prevent it from happening again if the sanity testing fails? So let us explain the answer to this following question. To configure your Git repository to run code's sanity checking tools before any commits, you can use the Git hook. Now Git hook are scripts that run automatically before or after certain Git events, such as committing, pushing, and receiving. There are a few steps to set up a Git hook to run code sanity checking the tools before the commits. Now, first step is by navigating to the Git hook directory in your local repository. And the second step is create a file called pre-commit in the Git hook directory. And then you can also add the following pre-commit files, which you can see here on the screen. So I'll explain each and every line. What does it mean? Now, the first line in the code is bin bash. Now, a bin bash is a shebang line used in the script files to set bash that are present in the bin directory as a default shell for executing commands present in the file. It defines an absolute path to the bash shell. So to put it in simple terms, it is used for executing the script using the bash shell. Now the second line of code is run code sanity checking tools. Now the line hashtag run code sanity checking tools is a command that provides a brief description of the following code. So the hash symbols indicates that everything followed on the same line is a command and is not executed as a part of the script. Now the line /run code sanity check.sh runs the run code sanity check.sh script. Now the / at the beginning of the line specifies the current directory, so the script is executed from the current directory. Now this code will typically be used in the Git hook script that runs code sanity checking tools before commit. The hook will run the run code sanity check.sh script to perform the sanity checks and then check the exit code of the script to determine whether the check pass or fail. If the checks fail, the hook will abort the commit and display an error message. Now we're coming to the last line of this code. This code checks the exit code of the previous command, which is the run code sanity check.sh script in this case. Now as you can see on the screen, the $ and question mark variables hold the exit code of the previous command. The if-end statement then checks whether the exit code is not equal to 0. If the exit code is not 0, it means that the run code sanity check.sh script has failed. In this case, the if statement will execute the code inside the then statement. which display an error message and exit the script with an exit code 1. See, this has failed, committed abort, and then it will exit it. Now the exit 1 command causes the script to exit with an exit code of 1, now which indicates that the script has failed. The if statement is then closed with the fi keyword, which stands for if finish. This code will typically be used in a Git hook script that run code sanity checking tools before commits. If the sanity checks fail, the hook will abort the commit and display an error message. The exit code of the script will then be checked by the Git system, and the commit will be rejected if the exit code is not 0. Now we can make the pre-commit file executable by running the following command. Now the chmod command stands for change mode and is used to change the permission on a file. Then as you can see here, the +X flag tells the chmod to add execute permission for the file. The +X flag tells the chmod to the user who owns the file. In this case, the command is adding execution permission for the pre-commit files to the user who owns the file. Now this is typically done to make a script file executable. Now this command will typically be used in a Git repository to make a hook script executable. Git hook are scripts that run automatically before or after certain Git events such as committing, pushing, and receiving. Now in order for the hook script to be executed, it must have an execute permission. So that's why we have the chmod +X. The chmod +X command allows the hook script to be executed. Now every time you try to commit changes in your repository, the pre-commit hook will run the code sanity checking tools defined in the run code sanity check.sh script. If the sanity checks fail, the hook will abort the commit and display an error message. Now to prevent this from happening again, you can either enter fix the issue that caused the sanity checks to fail or modify the run code sanity check.sh script to ignore the failing checks. Now let us move to the last question of this DevOps interview question for the advanced level. The question is, how can you ensure a script runs every time the repository gets new commit through the git push? Now to ensure that the script runs every time the repository gets a new commit through a git push, you can use the git hook called post receive. The post receive hook runs on the server side after all the refs have been updated. To set up a post receive hook, you have a certain steps. So the first step is you navigate to the hook directory in the bare repository on the server. Now a bare repository is a Git repository that does not have a working directory and is used to push and pull from. Second step is you have to create a new file called post receive in the hook directory. Then the third is you have to add the following command line onto the post receive file. Now I've already explained you what bin/bash is, so let us move on to the second line of the code, which is ./runscript.sh. As you can see, the line #run the script is a command that provides a brief description of the following code. The hash symbols indicates that everything follows in the same line. #run the script is a command that provides a brief description of the following code. Now the hash symbol indicates that everything follows it on the same line is a command and is not executed as a part of the script. Now the line ./runscript.sh runs the following script. Now the / at the beginning of the line specifies the current directory. So the script is executed from the current directory. This code will typically be used in a script or command that run other scripts. The ./runscript.sh command will execute the run script.sh script. Now the script will be any script file with executable permissions such as bash script, a Python script, or a batch file. Now the script could perform any desired action such as running, testing, or building a project, or even deploying the code. The script will run every time the containing script or command is executed. Now the next step is make the post receive file executable by running the following command. Now every time a commit are pushed to the repository, the post receive hook will run the runscript.sh script. Now if you want the hook to run on a local repository, you can use the post commit hook instead of the post receive hook. The post commit hooks run on the client side after the commit is completed. With this, we have come to the end of today's session. I hope at this point you are confident enough to attend your DevOps interview. If in case you have any doubts or queries, then make sure to leave it in the comment below. Thank you and happy learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!